Hi everyone, my name is Alejandro Sanchez and today we are going to discuss about ethical data usage and ethical data usage, but we are not going to give it in a theoretical way. We are going to go just directly using one data set and see what we learn in class using SQL, relational diagrams, entity relation and everything adapted to a data set. Okay, so here we are going to learn how to ask questions to our data set and how having a good relational model can give us valuable information. So this is the index we are going to follow in the presentation. Okay, as well we follow more or less the same order in the report. I know it's a bit long report, but we use like a lot of coding, so I prefer to explain everything really good in the report. So first of all, we will talk about the introduction, how we did the data cleaning part, that we use Python before using SQL, and after that, how we explore the data set, how can we reach to one conclusion, how to visualize the data. Once we have that clear, we can insert the data into SQL and we can start with the step number 4, that is the queries. Okay, we have 8 queries to answer and we have some extra queries that we are going to present later. After that, we are going to present some kind of discussion of how can we use the data in an ethical way, in an unethical way, and after that to reach to our objective of the project, that is giving some recommendations and some conclusions about this. Okay, after that, in the document, in the report, we have all the references, all the appendix we use, the code for SQL, for Python, so we are not going to spend any time here. Okay, as we said here, every company now is a data company. We can see this data is incredible. 500 millions of tweets every single day. That's a lot. So what does it mean? That from now on, if you are a good company, you need to have a good data department, and you need to have a good data framework for all your entire company, not just for the data people. Okay, so it's very important using data and use it in a ethical way. For which purpose? We will see the purpose at the end. Okay, which data set we chose? We chose the retail data set because I thought that e-commerce didn't have enough information. It only has 8 columns, so we prefer to use retail data set and try to analyze the consumer behavior. We have 2 computers, sorry, that I forgot to mention, because in this one we have like the presentation, and in this one we have the queries and all the code. And if I scroll here, let me see, if I scroll here, we have like the whole report. Okay, so maybe we will be switching between the computers. Okay, the most important 2 tools that we need to explain. Okay, first of all, SQL, that is what we have here, is where we use the queries, where we answer to the questions that are proposed in the assignment. And after that, the McKinsey & Company article about how data ethics is what is and how to use it. Okay, a lot of the references in the report here are from data ethics, from that article, so we will mention it a lot. Okay, and just a bit about the context. Okay, so is what I have been saying is explore the data set and see how SQL can give us very important information. First of all, about the data set, as we can see here, we have around 10,000 of rows. That is a really good data set, comparing maybe to other data set that we just have 100 data points. We can't do anything with this. This is a real company, and we have 21 columns, 21 variables that we can see all of them here. As we can see this is part of the code that we use with Python. Okay, this is data.info, the function 9994 in all of them. Okay, so that means that we don't have any empty values, missing values. so we can proceed with the analysis. Also here we are using the function .describe, okay, this will be very useful information only for the numerical values, just to have a look to the box plot after that. And about the libraries we use, libraries are like a package of functions that we don't need to develop before using it, so they are already developed in these libraries, and we can use it. Okay, so we are using basically pandas for data extraction, not visualization, for manage a big amount of data, numpy for doing numerical calculus, and these last two, matplotlib and seaborn, for some kind of visualization tools. Okay, the data cleaning, the most important thing, checking the missing values. We don't have missing values, that's cool. Okay, we don't need to, for example, fill the missing values using the median or the mean. Also duplicate values, two rows that means the same, we don't have that, so we can continue with the analysis. And one important thing that I spend a lot of time in this is about the format of the dates. Okay, as we can see here, the dates is not in the correct format, it's not year, month, day, so it's in another format, and if we add the data set to SQL like this, it will give us an error and we can't import the data. So cleaning this is very important, and changing the data format. Okay, and after that, two more important mistakes is, first of all, when we have one product. Corta aquí. Okay, sorry that I need to cut the video because these letters were in white and you couldn't see from there. So let's continue with the analysis. The first error that we have is when we have a same product name with different IDs. That means an error because the ID needs to be a unique identifier. We can see here like different names with the amount of different IDs that they have. So what basically what we did is, okay, if you find one name with different IDs, just forget about the rest of the IDs and focus on the first one. Okay, keep the first one and remove the rest. Mathematically speaking, we can express this condition here, as I studied maths before and I understand better the things like this. So basically it says that for every single name, if you have different, that is letter M, if you have different IDs, that is letter P, if you have two pairs MP and MP prime, P and P prime needs to be the same ID. So that is like the unique condition for the IDs. And the opposite happens when one ID has different products name. Okay, here we express the condition at the opposite, so M and M prime needs to be exactly the same. What we did here is we start like a tracker. Okay, if it's the first time the code sees like this per name and ID, you keep it, and after that, if you see a new one, what you need to do is create a new ID. So we have like unique pairs of name and ID of M and P. Okay, so once we have finished this, here we have a data exploration. I need to hurry up because the time is going to finish. And we can see like the box plot and the outliers. We are not going to remove any outliers because all of these outliers give us information. Okay, and for example, this last box plot that is about profit, we can see it here very good. So we needed to do a transformation using logarithm, and we can see it here. Okay, the distribution is a good company because the mean and most of the points are to the right. Okay, in a positive way. So it's a profitable company, we could say. I mean, by the moment. And a bit more of data exploration. These two graphics here, we compare like the sales with the winning per region. Okay, so we can see like which sales give us, which region has more sales and more profit. Sales is color blue and orange is profit. Okay, and here we can see also a distribution of the points between the sales and the profit. We can see like, for example, the green products that are expressed here has a negative relation to the with the profit. Okay, on the other hand, the red points has a positive correlation. So the normalization process, basically we have been 2 months speaking about this. First normalization form, all the data points needs to be indivisible. You cannot have like name, surname, and another surname. Okay, so that's what I said, atomic values. Okay, second normal form is eradicating the dependent functionary. Okay, so you can't have any dependent functionary. As it says here, everything needs to depend on the primary key of each table. Okay, and the third normal form needs to be in second normal form, and we need to remove as well the transitive relationships. Okay, so when we have that, we have we have everything, the normalization process finished, and we can create the ER diagram. But if we see here in the report here, I explain all the different relationship, one-to-one, one-to-many, many-to-many. Okay, basically is in this chart explain it. Okay, one-to-one is one assignment, one-to-many is that one on the left can have many on the right, and many-to-many basically that many on the left can have many on the right. Okay, so like this we create our ER model. We have 4 different tables. This is a M2N relationship, so it creates a table. We have customers, we have orders, we have sales, and we have product. Okay, here in the black letters in bold, sorry, we see the primary key and the rest of the attributes that we have. Okay, so let's go with the queries. We have here the code. We can explain it as well by the time we see the queries. First of all, is creating the tables, following the diagram model, and putting like the correct type of the variable, if it is a bar chart, a decimal, a date, or whatever. Okay, we need to use this table. So for example, if we start asking for the queries, what's the distribution of the customer segment, and each segment, here we see how we did it is select the variables we want to do, we want to choose, count it from the table of customers, and after that here we can change if we want a chart, if we want to choose a text, or if we just want the table. Okay, so to don't make the video very longer, we are just going to pass it through it and comment it, and see here we can see the code that it is working very good. As we can see here, most of the customer are consumer, and the other 50% is divided between corporate and home offices. Okay, what are the top 10 city customers? So we can see it here: New York, Los Angeles, Philadelphia. After that, we are going to see this in a heat map. Okay, so basically this is a chart, but I think it's not the best way to visualize it. What are this is question number 3 that we have it here, like the most frequently products purchased per category. We have here the whole table, and we have here like the 3 different tables: consumers, corporate, and home office, divided in category, purchase count. Okay, we can see that the order is the same in everyone: office supplies, furniture, and technology, more or less the last 2 with the same amount. Moving on to the next query: which product has the highest sales? Here we have another table as well that says here is the highest products sales, and here is the lowest. So maybe we need to give a bit more of potential, or a bit more of ads to these products, because it's the products that our customer prefers, and we should think about removing all these products because nobody buy it. So maybe we are losing money, time, and everything. How many customers have made more than one purchase? Okay, this is very important information. This is 766 unique customers. because most of the customers they buy they buy more than one product. And if we continue with the distribution of the postal codes that we have here, the code, okay, this is a bit more tricky than the codes. This is question number 4. This is select, and we need to use as well the group by. Okay, we use the function group by to group by the postal code. We count it, and we group it by. Okay, here we have the table, but we use some code of Python here to show it like in a heat map, and this is a file that we have that you can increase and you can make it bigger, zoom it or no. And this is in Python and this is in SQL. What else about the queries? Okay, the distribution of the customers based on the frequency, I mean in the numbers of order. If we use the query just like this will give us just an account, okay, but we ordered by the biggest one. So this is this output, and if we want to see like the distribution that follows, that is a normal distribution, we have another code here that is like select the order frequency and count it and group it by customers and show the distribution. Here is with SQL and here is the code with Python. Okay, we see that both of the distributions are the same one, following more or less the normal distribution. And which products has higher discounts? Here we have like, okay, what happened before? Maximum of discounts 0.8. These are all the products. If we execute here and we did like inner join, okay, because we need to join some tables. Inner join means that just need to, if you inner join table A and table B, needs to be like the intersection, okay. For example, left join, we just get like all of the attributes on the left and we assign one attribute on the right, but it's not the case of the inner join, okay. And here we have like that most of the discounts are on consumer, the middle on corporate, and the last one on home office. We see some kind of relation with this free table, okay, with consumers, corporate, and home office, because maybe more discounts will give more products. And other queries, we don't want to spend a lot of time in here because I think I have passed a bit of the time. So, for example, customer lifetime value, that is dividing the total lifetime value by the number of customers. We have the amount of time that we expected from a customer, and here we have the top customers. Okay. So ethical, and just the last part, ethical usage and the data and ethical. For a good common framework of ethical, we can show transparency, informed consent. We can use some personalized ads to increase the benefits of the customers, and also we need to focus on the data anonymization and minimization, and of course data security. Always, you can't have the data just free and give it to other companies. You need to ensure data security. And some other unethical use, so get that information maybe to manipulate or targeting and upselling like the customer every single day. That's not fair. Lack of transparency, maybe if you don't reveal your data policy, and also privacy invasions through sensitive data. Maybe you collect more data than what you need. And over collation or long-term storage of the data. You don't need to have the data from 20 years ago, maybe just the data that is important, or maybe store data that you don't really like, directions that or addresses that you don't need to have. And this is related with the first one, like the targeted discounts. It's not very ethical. So conclusion and recommendation for ethical data management. is first of all have a clear framework, okay, as data ethics says on McKinsey, clear framework of the company, communicate that to the customers, and do anonymization techniques. Please, you can ensure that every customer has their own anonymite, or you don't need to have all the information. And data retention policies, that's what we said before, that it was unethical. And last thing, ensuring transparency. What you say needs to be followed by what you act, or how you act. Okay, so this is my whole project. This is, here we have the report that is in this screen. It's a bit longer, maybe 60 pages, and this is the presentation. But I have been working in this project a lot, so I would like to explain it good and to make clear that everything is made it by myself with some help of references, as we say here. I'm not native English, so every single text is corrected by GPT, the spelling and everything. So, and it helps me to write. Okay, so here we set this in the references, and that's it. Thank you so much, and see you in the next class.